Hey everyone, and welcome back to the channel. Today, we're diving deep into a fundamental skill for any software engineer or IT professional working with Linux: process management. Think of processes as the beating heart of your Linux system. Every application, every command you run, is a process. Understanding how to monitor and manage these processes is crucial for system health, troubleshooting, and optimizing performance. By the end of this video, you'll be comfortable with essential commands like ps, htop, and kill, and you'll even learn how to create a simple script to monitor CPU usage of a specific process. Ready to take control of your Linux environment? Let's get started. First up, let's talk about the ps command, which stands for process status. Unlike some of the other tools we'll explore, ps gives you a static snapshot of the processes currently running on your system. Imagine taking a photograph of all the activity at a precise moment. It's not real-time, but it's incredibly useful for quickly seeing what's happening. When you just type ps, you'll typically see processes associated with your current terminal session. But to get a more comprehensive view, we need to add some options, or flags, as they're often called in Linux. This is where ps truly shines, allowing us to filter and display exactly what we need. Two of the most common and powerful ways to use ps are with the AUX and EF flags. When you run ps AUX, you're asking to see all processes, including those owned by other users, A, with detailed user and owner information, U, and even processes not attached to a terminal, X. This gives you a broad overview, showing things like PID, process ID, CPU and memory usage, start time, and the command that launched the process. On the other hand, PSEF provides a full format listing, often preferred for its clear display of the process hierarchy and parent-child relationships. Both commands offer a wealth of information, making them indispensable for initial system diagnostics. Getting familiar with the output columns is key to interpreting what your system is doing. Now, viewing all processes is great, but what if you're looking for something specific? This is where the power of pipes and grep comes in handy. Grep is a command line utility for searching plain text data sets for lines that match a regular expression. By piping the output of PSAUX, or PSEF, to grep, you can filter the results. For example, PSAUX grep Chrome will show you all processes related to the Chrome browser. A neat trick is grep, process_name, with square brackets around the first letter. This prevents grep from matching its own process in the output, giving you cleaner results. This combination is your go-to method for quickly locating a rogue process or confirming if an application is running. Moving on from snapshots, let's introduce top. While ps gives you a static view, top provides a real-time, dynamic display of your running system. Imagine watching a live dashboard rather than looking at a photograph. When you launch top, you'll see a summary of system information at the top, including uptime, load averages, and task summaries, followed by a list of processes sorted by CPU usage by default. It updates every few seconds, allowing you to observe how CPU and memory usage fluctuate. Top is your primary tool for identifying processes that are currently consuming significant system resources, making it invaluable for performance troubleshooting. Top isn't just a viewer, it's also interactive. While running top, you can press various keys to perform actions. For instance, pressing K will prompt you to enter a process ID, PID, and then ask for a signal to send, allowing you to terminate a misbehaving process. Pressing R lets you renice a process, changing its priority and influencing how much CPU time it gets. And of course, Q will quit top and return you to your terminal prompt. Understanding these interactive commands can significantly speed up your diagnostics and management tasks directly within the top interface, without having to open a new terminal. While top is powerful, top takes process management to the next level. Top is an enhanced, interactive process viewer that offers a more user-friendly interface than top. It's often not installed by default, but it's a must-have for many Linux users. Installation is straightforward: sudo apt install top on Debian/Ubuntu or sudo dnf install top on Fedora/RHEL. Once installed, just type top to launch it. You'll immediately notice the difference: a colorful interface, clear meters for CPU and memory usage across all cores, and an intuitive layout. If you find top a bit intimidating or old school, top will feel like a breath of fresh air. Top really shines with its array of convenient features. It supports vertical and horizontal scrolling, allowing you to navigate long lists of processes and see full command lines. Unlike htop has built-in mouse support, making it easier to select processes. You can also use function keys for quick actions, F3 to search for a process, F4 to filter the displayed processes, and most importantly, F9 to send signals and kill a selected process with just a few keystrokes. It also offers a tree view, F5, which graphically displays parent-child relationships, making it much easier to understand how processes are spawned and related to each other. These features combine to make htop an incredibly efficient tool for detailed process inspection and management. Eventually, you'll encounter a process that needs to be stopped. This is where the kill command comes in. Kill is used to send signals to processes. The most common use is to terminate them. When you run kill, PID, it sends a signal 15, which is a polite request for the process to shut down. This allows the process to perform any cleanup operations before exiting. However, if a process is truly stuck and unresponsive, you might need to use kill-9, PID. This sends a signal 9, which is a forceful, immediate termination that cannot be ignored. Use kill-9 with caution, as it prevents the process from cleaning up, potentially leading to data corruption or orphaned resources. For quickly terminating all instances of an application by name, kill-all, process_name, is a handy alternative. To make this practical, we've prepared a small project for you. In the accompanying repository, you'll find two simple shell scripts, dummy_process.sh and monitor_cpu_usage.sh. The dummy_process.sh script is designed to run indefinitely, consuming some CPU cycles, so we have a target for our monitoring and termination exercises. To get started, navigate to the scripts directory within the project, make both scripts executable using chmod +x, and then launch the dummy process in the background by running /dummy_process.sh and. The ampersand at the end is crucial. It detaches the process from your current terminal, allowing you to continue working while it runs. Pay close attention to the PID that the script prints, we'll need that for the next step. Now, let's see how we can monitor the CPU usage of our dummy_process.sh using a custom script. The monitor_cpu_usage.sh script is designed to continuously fetch and display the CPU utilization of a specified process. You can provide it with either the PID you noted earlier or the process name. For instance, ./monitor_cpu_usage.sh, PID, or ./monitor_cpu_usage.sh dummy_process.sh. Internally, this script leverages the PID, %CPU command, which specifically extracts the CPU usage percentage for a given process ID. It then prints the timestamp and the CPU usage every 2 seconds, giving you a live feed of how busy our dummy process is keeping your CPU. This demonstrates how you can build simple, yet powerful, monitoring tools using standard Linux utilities. Finally, with our dummy_process.sh actively consuming CPU and being monitored, let's practice terminating it. This is a crucial skill for freeing up resources or stopping misbehaving applications. First, ensure you have the correct PID of your dummy process. You can always confirm it again with /grep dummy_process.sh if you've forgotten it. Once you have the PID, simply execute kill PID_of_dummy_process. This sends the polite signal. If for some reason it doesn't terminate, you could try kill-9 PID. After issuing the kill command, you should observe that our monitor_cpu_usage.sh script will eventually report that the process no longer exists, and htop will also show that it's gone from the process list. This confirms successful termination, and you've just taken direct control of a running process. And there you have it. A comprehensive overview of basic process management in Linux. We've explored how to get a snapshot of processes with PS and its powerful filtering capabilities with grep. We then moved into the dynamic world of htop and its enhanced counterpart, top, for real-time monitoring and interactive management. Finally, we learned how to gracefully and forcefully terminate processes with kill and even built a custom script to monitor CPU usage. Mastering these tools will give you immense control and insight into your Linux systems, empowering you to troubleshoot, optimize, and maintain stable environments. Keep experimenting with these commands, and soon they'll become second nature. If you found this video helpful, please give it a thumbs up, share it with your fellow engineers and students,